Okay, fine, let's start. In the last video we have discussed about Grashof's criteria, but we have discussed for a 4R mechanism, which means in the 4-bar mechanism all the links are connected using a revolute pair. Okay, today we are going to discuss the Grashof's criteria for a slider crank mechanism. Okay, so this is the slider crank mechanism where this link is the fixed frame and this is the crank, this is the connecting rod, this is the piston cylinder. Okay, so this is the sliding pair. Okay, now I need to know what do we mean by Grashof's criteria. It means whether we have a link which can have a full rotation. Okay, now generally which link I have to have a full rotation, and that's a crank, right? So I need to check whether a crank will have a full rotation. Okay, so now in this slider crank mechanism we have also shown that if there is an eccentricity, this is the axis, but this crank has been fixed at this point. The gap between this axis, the sliding axis, and this point, the shortest distance, is known as eccentricity, which is denoted by E. Okay, so if there is an eccentricity, then along with the eccentricity, how to use this Grashof criteria for a slider crank mechanism. That's what we're going to see today. Okay, so as we mentioned in the earlier video, that the shortest link will have a complete rotation. Okay, so for this case we want this link, the crank, has to have a complete rotation. Therefore we're going to consider this as S, okay, to represent the smallest. Okay, now I'm going to do something because Grashof's criteria we know for 4R mechanism. So what I'm going to do is I'm going to replace this mechanism, okay, into a 4R mechanism. How am I going to do? So by replacing this sliding pair or prismatic pair into a rotating pair or revolute pair. Okay, so how am I going to do? So instead of this I am going to remove it and I am going to replace it with a link, okay, which is very long. Okay, if it is very long, then I can have if it is very long, if the radius of that link is very long, the radius of the curvature will be very small. Okay, and if the radius of this or the length of this link is very long, it goes to infinity, then I could say that the curvature of that arc which that link makes is almost 0, so that it's moving in a straight line. We can assume like that. So if I replace, it's going to look like this. Okay, it's going to look like this, and it keep on going to infinity. Okay, I have replaced that one, but what about the fixed frame? Okay, so fixed frame I have to put it in this picture in the 4R mechanism, right? So fixed frame is the one which connects this point as well as the bottom end of this link, right? So that's our fixed frame. So that's what this link is. Okay, so one end is connected over here, another end is connected very down. Okay, so that these two things are going to be in parallel, and at infinite these two things going to meet. So that's the idea. Now what is the length of this one, which is infinite, what is the length of this one, which is also infinite. Okay, among these two things, what I'm going to call this one as L, okay, to represent that's the largest link. Okay, why this is not the largest link is because the length of this one is slightly more than the length of this one, and that extra length is this gap, because from that point it ends up to here, it ends at this point or at this line, but this extend a little further, which is the amount E, the eccentricity. Okay, so therefore I'm going to call this as L, the length of this as L minus E. Okay, let me call that as Q. Okay, and the length of this one is P. Fine. Now I'm going to use the Grashof's criteria. This is the Grashof's rule, and in this equation I'm going to replace Q with this equation. Okay, if I put L minus E in the place of Q, I'll get this equation. Okay, and in this equation I'll cancel L at this side and this side. Okay, so that, and I'll take this E to this side, so that minus E will become plus E. Finally I will end up with this equation. So what does this mean? It means the length of this crank, okay, plus the eccentricity should be less than or equal to the length of the connecting rod. So this is the Grashof's criteria for a slider crank mechanism. Thank you.